Welcome to Video 1 for this unit on functions. In this video, we're going to focus on functions and function notation. Let's look at the relationship between the amount of time since a plane takes off in seconds and the plane's height above the ground in feet. Here is a graph that shows that the height of a plane is a function of time since takeoff. These two quantities form a function if time is the independent variable, the input, and height is the dependent variable, the output. This is because at any amount of time since takeoff, the plane could only be at one height above the ground. A function is a relationship between two quantities where there is exactly one output for each input. For example, the point 125, 400 on the graph tells us that 125 seconds after takeoff, the height of the plane is 400 feet. At that moment, it cannot be simultaneously at two different heights. The two quantities do not form a function, however, if we consider height as the input and time as the output. This is because the plane can be at the same height for multiple lengths of time since takeoff. For instance, when the plane is 1,500 feet above ground, it is possible that 275 seconds have passed. It is also possible that 300 seconds or some other amounts of time have passed. For an input of 1,500 feet, there are multiple possible outputs. So, the time since takeoff is not a function of the height of the plane. For any relationship, if any input has multiple outputs, the relationship is not a function. Here are graphs of two functions, each representing the cost of riding in a taxi from two companies, Friendly Rides and Great Cabs. For each taxi, the cost of a ride is a function of the distance traveled. The input is distance in miles, and the output is cost in dollars. The point 2, 5.70 on one graph tells us the cost of riding a Friendly Rides taxi for 2 miles. The point 2, 4.25 on the other graph tells us the cost of riding a Great Cabs taxi for 2 miles. We can convey the same information much more efficiently by naming each function and using function notation to specify the input and the output. Function notation is a way of writing the outputs of a function that you have given a name to. If the function is named f and x is an input, then f of x denotes the corresponding output. It is read f of x and can be interpreted to mean f of x is the output of a function f when x is the input. The function notation is a concise way to refer to a function and describe its input and output, which can be very useful. Let's name the function for Friendly Rides function f. Let's name the function for Great Cabs function g. To refer to the cost of riding each taxi for 2 miles, we can write f of 2 and g of 2. To say that a 2-mile trip with Friendly Rides will cost $5.70, we can write f of 2 equals 5.70. To say that a 2-mile trip with great cabs will cost $4.25, we can write g of 2 equals 4.25. These three examples show us that function notation is a concise way to refer to a function and describe its input and output. Thank you for watching video 1 of 7 for this unit on functions.